In C7, it was a little bit different than the earlier ones that you were dealing with, the FF, the F parallel, the F perpendicular, all those things. Here, we're going to have that same concept. We have a box on a ramp. This is going to be 68.9 kilograms. So we've got that. The coefficient of friction is 0.45, so my mu is 0.45. And the angle that it's inclined to here is 43.8 degrees. We want to know how hard we have to push on the box to get it to move at a constant speed up the ramp. So what we were typically doing was just putting a box on a ramp and letting it slide down, but this time we are pushing it up. So if I'm pushing it up, then my applied force, of course, is going to go this way. Well, if I'm pushing it at a constant speed, then all the forces are balanced. But what force is my applied force fighting? Well, the only force that always pulls downward is, of course, that parallel part of my weight. So this would be the F parallel. So again, F parallel can only go down because it's a component of weight, and weight can only go down. So it's going to travel down always, always, always. But normally, when the box was going down, the parallel was pulling it down, and friction was trying to pull it up. But in this case, the motion is up. So now friction also wants to pull down. So in this case, we have the friction and the parallel force are both fighting what I'm doing. And if I'm traveling at a constant speed, then these forces are balanced out. So my applied force here is just going to equal the parallel force plus the friction force, because they are both working together against me. So to figure this out, of course, now all I have to do is blindly plug into my two formulas. So I got it made. The F parallel formula, of course, was just mg sine theta. So I know my m was 68.9. I know g is 9.81. And I know my angle was 43.8. And of course, I'm in degrees. That tells me I have a total of 468 newtons caused by the parallel force. Now, to find the friction force, what I'm going to do is say my friction force formula is mu mg cosine theta. So the mu, of course, is 0.45, and the m is the 68.9, g is 9.81, and again, my angle is just that 43.8. Plugging this in, I find I get 220 newtons. So if I add the 468 plus the 220 newtons, that's going to give me a total force of 6, those letters look beautiful, don't they? 688 newtons. But my mu only had 2 sig figs in it, so we're going to round that off to 690 newtons. And so I'll write that a little more legibly for you.